Hello, welcome back to algebra class. Hopefully you're having a good day today. Today we're going to be talking about factoring differences of squares. Our objective today is to be able to factor and solve differences of squares. In order to be able to figure out some differences of squares, we need to know a couple things. First of all, a perfect square is a rational number whose square root is also a rational number. Basically what I'm telling you is numbers that can be gotten to by multiplying two of the same number together. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, x times x is x squared, 2x times 2x is 2x squared, x squared times x squared is x to the fourth. Those are just some examples. They are not all, but basically what I'm saying is you have to be able to multiply a number by itself to get to that number in order for it to be a perfect square. So we actually have a shortcut for factoring today that we are going to be using. It is called the differences of squares. That basically means if we have a perfect square minus another perfect square, we can take the square root of those perfect squares and write it as a minus b and a plus b. There's a couple things that have to be true in order for this to work. The first and last term of each polynomial has to be a perfect square. In the factored form, the a's and b's are the square roots of those perfect squares, and the sign has to be subtraction. If the sign is not subtraction, we cannot use differences of squares. Let's go ahead and apply this example. So I'm going to show you two different ways to do it, and then we will go ahead and use our shortcut here from here on out. So this is our original long method, and I'll go ahead and show you how the normal method we would do would work here. So we are actually missing a b value, so we would rewrite this as x squared plus 0 x's, because we have no b term, minus 25. Now usually we would draw our box. We'd put x squared here. We'd put minus 25 here. In this case, we'd want it to multiply to negative 25, but add to 0. So we would try negative 1 and 25. We get 24. Negative 2 doesn't work. Negative 3 doesn't work. Negative 4 doesn't work. Negative 5 works. And 5 is the other number there. That adds to 0. So we would know it would have to be negative 5x and 5x. We can then factor this, so we would have x right there, 5 right there. X times x is x squared. X times negative 5 is that negative 5x. So when we do that, we get the answer of x plus 5 and x minus 5. This is one method to use. So you are free to do that if you'd like. Basically, just add that 0x in the middle there. Or if you notice our rules, you can actually use a shortcut method on this. So if you look, we ask ourselves, is this a perfect square right here? And yes, it is. Is there a minus sign between the two numbers? Yes, there is. And is this a perfect square? And yes, it is. So we can actually use our differences of squares shortcut. All we have to do that is take the square root of our first term, which the square root of 16 is 4, and the square root of m squared is m. And we take the square root of our last term, which the square root of 9 is 3. And then we just do a plus version and a minus version. So we rewrite it as 4m plus 3 and 4m minus 3. So once again, two ways to do it. You choose which way you like, and it is your choice from there. Let's go ahead and look at our next problem. So we have 75x squared minus 12. So we do have a GCF right here. It is actually 3, so we can divide both of these by 3. So when I do that, I rewrite it. We have 25x squared minus 4. So that leaves us with two perfect squares. So 25x squared is actually a perfect square. We have a minus sign, and we have 4 is also a perfect square. So the square root of 25x squared is going to be 5x. The square root of 4 is 2. So I need to have a plus version or minus version, so I have 5x plus 2 and 5x minus 2. Let's go ahead and look at our next example. There is no GCF that we can pull out, so now we just ask ourselves, do we have a difference of two numbers? Yeah, so there's a minus sign. X to the fourth is a perfect square. 81 is also a perfect square. So x to the fourth, the square root there is x squared. The square root of 81 is 9. So we just write down our plus version and our minus version. So we have x squared plus 9 and x squared minus 9. This time we're not just factoring, it's actually asking us to solve. So after we solve this, we need to use the zero product property. There is no GCF that we can do here, but we do have a minus sign. And we do have a perfect square here. And this is actually a perfect square as well, and I'll show you how to break that down in a second. So to do the factoring, the square root of x squared is simply x. The square root of 4 over 49, to do that, you just take the square root of the top and the square root of the bottom. So it's going to be 2, because the square root of 4 is 2. Square root of 49 is 7. So my final answer would be x plus 2 over 7 and x minus 2 over 7. And that equals 0. Now I need to use the zero product property from here. So I'm going to say x plus 2 over 7 equals 0. And I say x minus 2 over 7 equals 0. I solve both of those, so I'm going to subtract 2 over 7 on this side, so I get x equals negative 2 over 7. Over here, I'm going to add 2 over 7, so I get x equals 2 over 7. Make sure to write your final answer in set notation. So it's negative 2 over 7, comma, 2 over 7. We have one more example to go, so let's go ahead and do that. So this time I actually don't have one side equal to 0, so I need to make that happen first. So my first step is actually going to be to subtract 50x on both sides, so I get 18x to the third minus 50x equals 0. There is a GCF here. It's actually 2, so I'm going to go ahead and factor that out. Or I'm sorry, it's actually 2x. We can take an x from there as well, so it's going to be 2x. So that's going to be part of our answer there. So we get 9x squared minus 25 equals 0. Now we do have a difference here. We do have a perfect square right there. And we do have a perfect square right there. So let's go ahead. The square root of 9x squared is going to be 3x. The square root of 25 is 5. So I need my plus version and my minus version. So I have 3x plus 5, 3x minus 5 equals 0. Now I have 3 factors, so I need to use the zero product property 3 times. I'm going to go ahead and do that. My first one is going to be 2x equals 0. Then I'll have 3x plus 5 equals 0. And I will have 3x minus 5 equals 0. So I'm going to solve all 3 of those. First red one, I divide both sides by 2, so I get x equals 0. Second one, I'm going to subtract 5 on both sides, so I get 3x equals negative 5. Divide by 3, you get x equals negative 5 over 3. Last one, I'm going to add 5 on both sides, so I get 3x equals 5, and then x equals 5 over 3. So I just write these in order here. My negative number is going to be my smallest number, so I'm going to go ahead and start with negative 5 over 3, comma 0, comma 5 over 3. So I actually have 3 different solutions on this problem. The reason we have 3 solutions is I have that cubed right there, so it's going to have 3 solutions. Usually we just have a squared, so we have 2 solutions. That brings us to our end of our lesson. Have a great rest of your day.